All right, so the next speaker, we're going to run onto it. Sander is the Chief Technology Officer at iBoot.com and a seasoned developer with over 4 decades of experience. Known for his post-agile mindset and innovative perspective, Sander has inspired teams worldwide to embrace critical thinking and continuous development. And what more do you want with that? So a round of applause, show some love to Sander. Let's welcome him onto the stage. Come on, you can do better. Keep it coming for Sander. Welcome, welcome. Oh. We have a little bit of a glitch with the microphone. 1 second. Don't mind me. I'm backing out slowly. Just don't look over there. Look over here. And don't mind. Did you notice that? OK, all right. Sander. OK, so I'll be right here next to him for a while. So I'll be your interpreter. All right, so you tell me your speech, and I'll tell it to the speakers. OK.
I'll do it in Dutch, and then you can do it in English.
Dutch and English, perfect. I'll be perfect. I know Dutch. I'll just do Google or ChatGPT. OK.
Oh, you really want to do this?
No. I don't want to do this.
I don't think Chat is going to keep up with my pace of talking.
You know what? You want to test it live? ChatGPT.
No, still doesn't.
You want to use this one? Sorry, Shanyi? Shanyi? You want to change it? No? OK. All right. We tried. So shall we do the ChatGPT play? Want to test it out?
No, I talk too fast for that, actually.
You talk too fast? Sure, yeah. We're getting sorted out. I was so excited to test ChatGPT, although he's saying that he talks too fast. I don't know. It's a challenge for ChatGPT. Who has actually used ChatGPT as an interpreter? Have you tried this with the voice? Anybody? Nobody? Oh my God, it's the best thing ever. I tried it with my mother-in-law in Hungarian. It actually works, folks. I was very surprised. Her and I were having a conversation. The phone was on the table. She was speaking Hungarian. It was translating to English. And then I spoke back and actually spoke Hungarian to her. And we had a fabulous conversation. It was so that impressed her so much that she wanted to use it in her pharmacy for others. I told her, I don't think it's going to be that performant. I think our normal conversation will be good. For medicines and prescriptions, I think it has its limit. So it was a fun play at that time.
Oh, not yet. Oh yeah, yes. Yeah, we're good.
All right, you got
cool.
Sander.
Finally, well done. See, that's what you get. Life is full of surprises, right? This is typical for our industry as well. So without further ado, I'm going to talk a little bit about the thing is, I've seen so many talks at so many conferences. I've done a lot of talks at conferences. And at some point, I was like, what can I still add that people might find interesting? And I'm like, I could talk about AI, but then, everybody does that already. And then I can talk about resilience, but a lot of people here talk about resilience. And I'm like, no, you know what? I'm going to talk just about my own personal journey as a developer. And then you might wonder, why are you doing that? Well, I think so we all learn the big things, the paradigms, the languages, the frameworks, and stuff like that. But it's the tiny little things that make our life different from, I think, any other industry whatsoever. So can somebody switch on the timer, by the way, so I can time it? So here's the thing. It's my journey, right? So I'm going to tell you a bit about what I do, what I've done, and how that works. So basically, I have 2 hobbies. And I like to travel. That's why I love being in Budapest. It's really great. And I like to write code. And that's what I do most of my time, actually. So this has been an extremely long journey. And I'll show you how long it was. Because in 1978, my dad was a mathematician. And he bought one of the first programmable pocket calculators, the HP 25. And you're like, what do we have to do with this? Well, I opened up the manual, and on page 1 it says, effortless programming. 1978, right? How hard could it be? So I opened up the manual, I looked at it. It's in Dutch, by the way, so don't bother trying to read it. It's impossible to read. It's less difficult than Hungarian, but it's more difficult than most other languages, I suppose. So I started reading this thing, and I was like, I can write some code with this. That should be possible, right? And I did. That's when I wrote my first line of code. Now, my dad, being a really meticulous person, he wrote down everything. He registered everything. He wrote down in the manual when he had bought the machine. So this is probably when I wrote my first line. Somewhere in the end of 77 or early 78, that's it. And so it's been a real long journey. And the thing is, writing code, or actually solving problems probably, it's all about learning, right? We can, in this industry, because this industry, well, it expands faster than the universe, right? So we will have more node modules than there are to fill a black hole pretty soon, and we'll catch up with the James Webb Telescope at somewhere. We'll drop up on the stage somewhere, and so we have to learn all the time. There is no avoidance, right? We cannot avoid not learning. And the question that comes up first to me is then, how do you learn? What does that mean? Now, really early on in my career, I found this framework. Actually, Alistair Coben found it for me, but and he said, well, there's these 3 stages that you can go by. First, you learn from somebody who's done it before, right? This is Karate Kid. You've seen Karate Kid, right? The older one, not the newer one that's like with the weird series and stuff, where he has to wax on, wax off. I never know whether it's this way or that way, but wax on, wax off. Well, let's assume it's this way. And then he has to paint the fence. And he was like, why am I doing this? Well, this is muscle memory, right? That is stage 1. And stage 2, you get to learn what it means when to apply these techniques, right? So he learns the crane technique, and it's actually an official technique. I didn't know that, but when I watched the movie. And he learns when not to use these things. And in the end, you transcend. That is when you start going, let's say, by intuition. Because that is basically what most of us probably will do, right? If people ask me, why is this code more beautiful than that code? And I can judge that, right? I can say, yeah, I like this code better than that code. And why exactly are there rules for that? I don't have them, actually. That's one thing I learned, right? So I think that the zen of this is that we tend to be guided by intuition. That is how I do my work. That doesn't really sound very scientific or like engineering, but for me, it's a craft, right? We're in the right place for that, by the way. So that's good. So I started reading up on learning a bit more, and I'm not an expert, right? I'm not a psychologist or whatever. I'm just a dumb developer, basically. And there's a book called Becoming a Technical Leader, and it was written by a guy called Gerald Weinberg. Now, Gerald Weinberg wrote about 78 different books of them, but this one has a really interesting story in it. And once you had this in your head, it never goes. So here's the story. He was trying to teach himself how to play pinball. And you might go, what does pinball got to do with programming? Well, a lot, actually. So his expectations were that he got better at it over time, and that it would grow like linearly, right? And then he started jotting down the scores, and he realized, putting that out in a graph, that it wasn't linear at all, right? There were these bumps in there where he all of a sudden got a bit better. And he started wondering what that was, right? So he put down the exact scores of the games he played in the local cafe in his town. And he realized that, well, actually what happened is that right before everything went up, or big time, let's say next level, there was this pothole in the scores, right? And then he figured out, what does that come from? Well, they come from running experiments. What? Running experiments? Yes. So I'll tell you one of those experiments. Many pinball machines have this nasty thing called multi-ball. Have you ever played pinball? You do, right? So at some point in time, you have multiple balls in play. And then you're like, now what? And the problem with multi-ball is, if you've played pinball, is that when you do that, and you try to keep all these balls in play, all of a sudden, they're all gone. Recognize that? No, you probably don't play pinball, right? You're of the next generation, I suppose. But it does happen like that. I tried it, and he had this strategy. He figured out, what if I keep my eyes on one of these balls, and whenever the other passes, I'll just bump it too, but I don't pay too much attention. It's like focus, right? It's like figuring out what card, or if you see the closing keynote yesterday, what card is missing. And so it's about focus. And he focused on that single ball, and he kept that one in play. Now, that was the experiment he ran, and he ran it quite successfully. He got better at it. And the funny thing is, I tried it actually a couple of years ago on a machine. I was at a party, and there were machines, And I broke the all-time high record on the machine with this thing. Now, I'm not particularly good at pinball, but it works, actually. So here's the thing, right? You have these ideas, or let's call it epiphanies, and it could be really big, right? You could read a book, and a book is like a stack of pages, and you could think, oh, yes, this is brilliant. I got my new ideas here. So I read the design patterns book when it came out, right, in '95, and I was like, that, right? So not sure if you have that too, but that was it for me, right? But there's a lot of like these tiny things, like the tiny dots, like the tiny potholes that happen throughout your life that make you a better programmer, a better person. But it's all about taste, right? It's like my taste might be different than yours. So, and the thing is, one of the things I learned pretty quickly is that it's not just about learning, it's also about unlearning things. And what do you mean unlearning things when you're a programmer? Well, learn to throw stuff away, for instance, which is really scary, right? Because we tend to love our code. We don't throw that away. Or, for instance, remove a lot of the abstractions that you find in your code. This has basically been my career, right? I found this on the internet, really cool graph. I started here, right, because I didn't know any better. I just wrote very simple code. And then I started working for larger companies and large financial institutions and governments and large consultancies, and you add layers of complexity. For different reasons, right? Because in governments and in banks, they don't know any other thing. In consultancies, basically, add more layers, you make more money. And it's a different motivation, right? So, and I got into like 11-layer architectures at that point in time, like in the 90s and early 2000s. And then I started to realize, basically after I stopped working for large companies, that I should be going on the way down. I should be striving for very simple code instead of very complex code. And writing simple code is a lot harder than writing complicated code. Complex code and complicated code is way easier to write. So you might say, I've been on a quest for writing super simple code. And then you might ask, so what does that mean, right? So, well, that means I'm going to introduce myself a little bit. This is me, very big picture of me. I'm a dad. I have 3 kids. They're all grown-ups. 1.5 live still with me. I speak a bit, I travel a bit, I write a bit, well, I'm basically a lifelong programmer. I write code every day, literally every day, by the way. And I'm currently the CTO for this e-commerce company in the Netherlands, nice company, and I'm trying to shape the future for them. So this is my social media. If you want to connect, feel free. I'm also able for that. But to show you that I'm a programmer, this is my name, right? I am actually double object-oriented. I was born this way, right? I couldn't help myself becoming a programmer. It gets worse, by the way. I'll show you where I live, which is in the Java Street in Amsterdam. This is literally the view from my window. So yeah, I write code. That's what I do. So, I contribute a little bit to open source. This is our framework for writing microservices in TypeScript. So, but I'm not going to advertise. Please star it. Please star it. So yes, a quest for super simple code. And I'll show you a whole bunch of these epiphanies that have passed in my career that have helped me to change, or to shape me in the way I am now. And that shaping, by the way, never stops, right? The stuff I'm learning now is not the same stuff that I was learning last year. Actually, if you look at your own code that you wrote about half a year ago, and you don't look at it in a way like, oh, that's ugly, I should change that, then you haven't learned anything, right? If you look at your own code from 10 years back, it should be really, really different. The style, the code you write should be different. And the thing is, you're never there, right? It does never end. There is no end to this learning thing in software development. That is probably one of the reasons that we all like it so much. So one of the very first lessons I had was from my mentor at my first job, a guy called Wim. Dutch name, Wim, doesn't matter. And Wim said, imagine walking in the desert and there's a thick fog, and you can't see anything, right? Now, the desert is like sandy things. And he said, well, there might be a wall somewhere in the desert. You might bump into it at some point in time, or you might not. That is basically what writing code is, right? You're trying to solve a problem, and all of a sudden, you're stuck. And you have no idea what to do, or where to go, or whose help to ask, except for ChatGPT, of course, right? But we didn't have it back then. Back then, we didn't even have the internet, right? I learned to code from books, basically. That was cool. So this is the thing. There's always this uncertainty that we have in what we do. And I think the great programmer Donald Rumsfeld, he must do Excel, right? He wears a tie. So he says, well, there's the known knowns. That's the stuff we know. And then it gets worse and worse. He says, well, there's also the known unknowns, the things we know we don't know. And that's fine, right? We can live with that. We can even estimate it. However, in our industry, there's a lot of stuff that falls into the category of the unknown unknowns. The managers at my current company continuously tease me with this. They're like, oh yeah, that must be one of your unknown unknowns, right? And that's when I try to make a choice whether to eat cheese or ham on my sandwich. But these are the things we don't know. And then he says, if one looks throughout the history, it's the latter category that tends to be the difficult ones. That's an underestimation, right? If you don't know what you don't know, what do you do? And that is a tough problem to solve. And then there's always the managers who say, yeah, I get all that with your unknowns, and with your agile bullshit and whatever, but when is my project done? And the problem is, if you don't know what you don't know, how would you know when your project is done? You make up a number, right? And the right number, of course, is 42, right? So that's it. And I literally do that. When I talk to the manager and they said, when is the project really done? We're now rebuilding the CMS. And he said, when is it done? You've already been on it for 3 months. And I'm like, well, the previous CMS has been developed in 15 years. So what do you expect? And he said, well, I expect that it's done for the end of the year. And he said, how long are you going to take? And I'll say 42. And then he knows that I don't know, right? That's a good point. So here's the thing. There's no such thing as productivity in writing code. It doesn't exist. And I'll explain to you why, really briefly. Because the thing is this. We do not produce stuff. It's not like we produce cars, right? If you're on an assembly line and there's been cars being assembled, you can say, well, by the end of the day, we have 2 cars assembled. We don't do that, right? It's not like, oh, we have 2 softwares by the end of the week or the end of the month or whatever, right? Or even we have 10 lines of code by the end of the day, because sometimes it's 0, sometimes it's 20. By the way, the average programmer annually writes about 10,000 lines of code. That's not a lot, right? But it's probably more than most do, actually. So that's the problem. We don't do this. We don't do productivity. And the reason for it is that most of the stuff that we do does not take place on a keyboard like it does on an assembly line. It's in your head, right? Actually, to be quite honest, I have code running in the back of my head all the time. I was solving a puzzle earlier, trying to write some code, and I checked it in, by the way, about an hour ago. And but most of the work is done here, right? And that means that it doesn't really fit well in the regular patterns that we have in the world, right? And Ken Beck said something really wise. So this is at a conference in Denmark in 2003, and he said, I'm not going to refactor the code just yet because the code doesn't know yet where it wants to go. And this was 2003. I was a bit younger. I'm like, what? What is he saying? What does that mean? And years later, I realized this is it, basically, right? This is it. I look at my code. I'm not going to change it. I'm going to go for a walk, have some lunch, do whatever I want to do, come back to the problem, and have a fresh view on it, and then I'll refactor the code. That is what I've learned over time, and that is really, really cool, actually. So here is the wise man. But it does mean that writing code does not fit well in time boxes. So if you work in sprints, who does work in sprints? Please stop doing that. No, I don't mean stop raising your hands. I mean stop working in sprints, right? They're useless. So also, it doesn't really fit well in 95 because our minds don't work like that. Our minds work like this, right? You get up in the morning, you're in the shower, and you're like, wait, that is the solution to this particular problem. And then your manager expects you to work from 9 to 12, go out to get lunch, and we have free lunch these days in the office, and then do it again in the afternoon, and then you're done, and you switch off your computer, done. That's not how it works, right? When I'm doing groceries in the evening and I'm in the supermarket, I'm like, oh, I could try that. That should probably work. You'll probably have that too, right? And that means that for us, it started to get like an addiction, basically, right? It's always in the back of my head. That's basically why I divorced the mother of my kids. She didn't really appreciate it. She's like, are you working again? And I'm like, what? I didn't hear her, right? So like, yeah, that kind of stuff. Anyway. So that is an interesting problem. What I learned over time is to travel as light as possible. And it's not just that I just travel with a bit of hand luggage when I drive somewhere. It's also, I try to get rid of everything that sits in my head and doesn't need to be in my head. And how do you do that? Well, you take away the complexity. Now, I'll tell you a little bit about complexity. This is Neil, and Neil says, Developers are drawn to complexity, like moths are to a flame, often with the same result. More or less the accent, but I'm not good at these accents. So that's the point, right? That's what we do. We are all drawn to complexity. And Gregor, I'm not sure if he's in the room, he was earlier, but he says that excessive complexity is nature's punishment for organizations that are unable to make decisions. Eat that, banks. So that's cool, right? And this is what we do. And we do this, all of us do this, right? And it's something we really need to get rid of. We do this premature optimization, and we do it with all of our code. I'll show you some sentences that people say, right? Developers say, like, oh, we might need this in the future. Eventually, we will need this. Or what if we want to replace this database by another at some point in time? Have you ever done that? I've been preparing my code with all these ORMs and whatever we use in between just to be able to do this. And I've never done this in 40 years. Why do we add this complexity to our code? We should not do this. So you need to mind the words and the sentences that make sense, right? It's like might in the future, eventually, later, what if, at some point in time. If you encounter those words in your own sentences, you need to think again. Really, this is an important point, right? Because premature optimization creates unnecessary complexity. Because if you do not need it now, you should not build it in. Code that is being built more generic than necessary is mostly not reused. In about 10% of the cases, it is used, actually. So get rid of this stuff, right? And solve the right problems. Right? So Ewart Wolf says, like, scalability is the #1 problem people don't actually have, but still solve. We probably all are solving scalability issues, right? A lot of us actually do not have them. So stop spending your time on that, right? It's a waste. And it gets worse because there's always Hofstadter's law, right? Take a moment to think about this one. It's like, it always takes longer than you expect, even when you take into account Hofstadter's law. That's our industry, right? So here's the most important lesson in this talk, probably. It's on the next slide, and it says, you can only spend your time once. And that means you need to spend it carefully. That means you need to spend it on the things that you value the most, right? You as a person, not necessarily even you as a programmer, or you as a family member, or you as a traveler. You need to pick wise what you do with your time, because it is very limited that we have. So the question I have everybody ask in my team to themselves when they come up with stuff is, do we really need this now? Or basically, I emphasize the word really. Do we really need this now? If the answer is, well, actually not, then you should not spend your time on that, because you don't have that time, basically. So what should you do? Well, you should favor simplicity, right? So simplicity is really, really hard. But try to imagine this. Code is not a product. Code is actually cost. Because every line of code that you write, you need to design it, you need to think about it. Well, you need to basically write it or have AI write it. You need to probably compile it, build it, put it through the pipeline, have it deployed to production. Then people come back to you and they say, well, this is not right, and you have to do it again and again and again. Every line of code amounts to a huge amount of effort. And that is something you probably should want to avoid. So that means simple code is always better, because simple code usually means less code. I have these sessions that I code with the people on my team, and I usually, well, I have a negative code churn, basically, on all of the code I write. I end up with less code than I start with all the time. And that's better, right? So this is an example of some test code in Jest, and you might say, well, it's not that bad. And I looked at it, and I'm like, I could do it in less lines of code. And I rewrote it into something like this. And it's just a little bit better, right? All these little things that you can do are just better, right? Because, well, the code that you don't have, you also don't need to maintain, right? And that sounds pretty simple, but that means that if you write less code, then that code should be better. So I ended up doing this. I ended up going to single statement functions. Now, this is TypeScript. I actually took this out of my code this morning, or this afternoon, actually. So these are single statement functions, right? And I really like this. And there, by the way, we have to talk about monads a bit, but this is monadic code. That means there's a lot of sort of pure functions, and the side effects are taken away by the promise. And that is typically what you can do. And the funny thing is that most of the code I write, or actually all of the code that I write, my thinking process has changed. It went into, I'm going to start every function that I write with the word return. And like, what? Does that make any difference? It makes a huge difference. It makes a world of difference because you reason in the reverse order. You're like, what do I need to end up with, and then how do I get there? Instead of, oh, let's run a bunch of code and if statements and blah, 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 and then you think, oh, I need to return something. It's a very different way of thinking about things, and that helped me to actually change the way I reason about code. I've been doing this for about a decade now, and it's in different languages. It doesn't matter. You can do this in any language. It works better in more functional languages, but you can also do it in like Java and C#, and no problem. I did it. So this is a nice, small thing that I learned myself. And then there's naming things. Naming things is really hard, right? Especially when you're writing Spring. It's like the abstract annotation config dispatcher servlet initializer. Okay, I get it. You can name a class that because it's very precise, very exact. But the problem with this is what people do in a lot of programming language, if they write a function and the parameters to the function in the signature have a particular type, they name the variables exactly the same, except not with a capital, right? They do this. This is code I just got out of an open source project from a friend of mine. This is Java. And well, the type is chat message context, and the variable is called chat message context. If you write single statement or short functions, there's no point in this. The reason we did this in the past, and I know because I've done this, is because in the past we did not have the full-fledged IDEs that we now have these days. We had editors. And if we wrote 80 to 100 lines of code in a function, which is what we did 40 years ago, and you declare a variable at the start, and you're 40 lines to go down, we did not have IntelliSense. So we didn't know what the type was of the variable at that point in time. So we had to guess. And how do you guess? Well, you name it in the same way. We don't do that now. They might have well called it thing, well, I would have probably called it context. But C would have also done, right? You can call a variable C because it's very local to the scope of this particular function. So I started doing that too. And actually, I started teaching my teams also to do this. So we you can do all sorts of nice things with names. For instance, this code, it has a profile repo. But why would I name my variable profile repo? It's ugly. It doesn't read well. If you name it like profiles, you can say this.profiles.my, which is basically the shortest function name I could find. But it's also like this.comments.findTopic. It's not comment.repo.findTopic. It's just ugly, right? So you can name it prettier and shorter, making it more readable. At least that's what I think. So I started doing this on all sorts of things like single character variables. There's nothing wrong with it. I know what this is. It comes out of the query parameters in my URL. So Q is good enough. Q means query. I could have query here. I just chose Q. Why? Well, it's obvious, and it's only one line of code. So why not? Also, all the code that you don't write is more secure. Think about that, right? Security is a big thing. Also, one more thing about code, and then I'll dive a bit into architecture, is do not do this. If you leave in commented out code, people will get confused, right? Who does this? Don't do this, right? It's not worth it. You get, unless you want to confuse people, right? That's nice. Like, you can write a comment that says, well, I'll finish this tomorrow, and just leave it in, right? See what happens. And but remove this stuff. We have version control systems, right? Distributed version control systems. If you want to look at what was there in the 2 days ago, go ahead, look into your history. You'll find it, right? And that's fine. So let's delve into architecture a little bit. Just a little bit. So to talk with the great programmer Charles Darwin, probably a COBOL programmer. He's that old, right? And I adapted his quote a little bit. He says, well, it's not the strongest of the architecture that survives, nor the most complex ones. It's the most adaptable, right? We all know that adaptable architectures survive more. Now, here's the funny thing. I wrote this book in Dutch, by the way, don't worry, in 2003, I think, about UML. Nobody of you knows anymore what the UML is. Doesn't matter. It's an old thing that didn't survive the time. But in that thing, I wrote about a simple architecture. And the funny thing is, I've been dragging that architecture along with me ever since. Now, I already had it, by the way, before I wrote the book. But and the thing is, I'm not going to say adopt my architecture. What I'm going to say is create your own very simple architecture and use it everywhere. And I'll show you some examples. I'll show you mine, actually. So it starts with the domain. Here's the entities and the value objects and whatever you might have, right? So around that, we have our repositories. Typical patterns from DDD, nothing wrong with it, pretty simple, straightforward stuff. Around that, we have, oh, there's one missing because it's white. Well, it's at use cases, basically. And use cases, what are those? They're like user stories for older people, and they're like, well, requirements, basically. And we have them in code, actually, because they tend to form a nice unit of our process logic. So that's nice, but they don't appear on the slide, so they're transparent, I guess. So, and then there's the resources. That's how you get in. This is apparently a service. And there's a way to get out to databases, other services, other platforms, whatever, right? This is a simple architecture. And the funny thing is, I've been building this shit in different languages. I found a repo recently of my one of my own projects in 2014 or something. It has the same structure. It has the same 4 folders with code in it. This is a C# project, by the way. And I found a repo in it. This is one of the repos coming from that project. It's a repository class. It implements the repository pattern. Done. That's it. Really easy to read. Same thing in Java. Well, functional style Java, actually, that is. And same one in Python, which looks a bit different. But it's the same thing, essentially. And one for my current client is it's a TypeScript project. We have a single stack. So I was really happy with the opening keynote yesterday. He said, well, use a single stack for everything. We do that, by the way. And we use that particular stack, and it works. So that pattern we apply everywhere. And the set of patterns that are in this architecture, they're just everywhere. Now, we do microservices architecture. And the problem with this microservices architecture is that we have about 120 repos. My team is 13 people, including me. That means we need to maintain these 120 repos. You might say, how do you do that? Well, they all have the same architecture. If I would open up any of these folders, like this one, it has this. I just did the screenshot, so and this is well, it has the same structure. And if we would open it up, I find those classes and those patterns, and they're everywhere basically. And you can do this in any language whatsoever. So I've been taking this along with me for years and probably even decades. Again, I'm not saying use this architecture, but find one for yourself, right? And there's lots of examples, and we'll strip all the complexity from it, right? Because in most cases, you do not need it. And in those rare cases that you do, you'll add a little bit of it, right? So, anyway, you can read more about this architecture. It's on the repo. And then, talking about complexity again, I was looking for a React state management library. Have you done that? Have you tried finding one? I did. So I got to a website that says, these are the 32 best React state management libraries. And I'm like, what? What do you mean there's 32 state management libraries? No, there are many more. These are just the best ones. I'm like, how many do I need, basically, right? And if you listen to Dan Nordstock earlier, he said, yeah, well, strip all that stuff you don't need, right? And I didn't need any extra. I realized that after looking at the state management library. Why do I need this? I can do this myself in like 5 lines of code. It's pretty easy. We do not have this complexity in our code. So let's get rid of it. And we did, and it worked fine, right? So get rid of that complexity. As a result, what I also learned with my teams over the years is that there's no such thing as best practices in this industry, right? What works in one stack, in one language, in one paradigm, in one company, in one project, in one repo, does not necessarily mean that it works in other ones as well. There are good practices. That's fine, right? There's lots of those, like high coupling, low cohesion, stuff like that, or like the Unix philosophy, right? Write programs that do one thing and do that really well. They all seem to go to, let's write code that does one thing. A lot of the code that I see around on this planet does not do one thing. It does way too many things and has all sorts of side effects and whatsoever. And that is not the right direction. Even Bob Martin, in all his wisdom, he was like, oh, I'll define the single responsibility principle. And it says, every module should have the responsibility over a single part of the functionality provided by that software. And you can easily spot when you're not going in the right directions. Like, this is a Python code file that I found in one of our repos. It has like 352 lines in a single class, a single thing, a single file. And then this is already too much for me. I looked at our new platform that we're building, the 120 repos. Altogether, those 120 repos have less than 60,000 lines of code. We removed all of the clutter from it, and that's really nice because it helps you go forward, right? So this again is a nice example. This is a repository class, and it has 5 gateways, meaning it goes out into 5 different sources, gets data from it, and does stuff with it. And it ended in code like this. This is, by the way, from one of my colleagues on my current team. Although it's still kind of nicely organized, I actually didn't like this code. I put it apart, and I like, make sure that everything does only one thing and does that one thing really well, particularly like Unix says, right? So that's the thing. So what helps in here? This is the complicated part of the talk, right? This is a part about monads. Have you heard of monads? Oh, now that's going to be hard, right? So here's the thing. At one point in time, I was in a Java project. Is anybody doing Java? Okay, so I can't joke about Java, right? Is anybody doing, what do you guys, what is the rest doing? Python? Who does Python? PHP? Rust? C#? JavaScript? TypeScript? It's like really mixed. That is really cool. You rarely have that, which means I cannot joke about any of these programming language. That's really silly. I usually do that. Anyway, so passing functions as parameters. And you might say, well, that's kind of normal. Well, it was not in 2014 until at that point in time, Java 8 came out. They're now at Java 21, I think. And they're going to 22. Nobody does that, by the way. Most people are still on 17 or 8 or whatever. But so you could pass functions as parameters. In C#, we could do that a long time before that anyway. In JavaScript, you can always do it, because you pass everything into everything in JavaScript, right? And then we found this Scala code base. Or actually, we looked at the Scala specs. Now, in the Scala specs, there's this thing called a try. And you're like, what is a try? And I had no idea. Guy I worked with on my team at an insurance company at that point in time, and he was like, I think we should try this out in Java as well. I'm like, what does it do? And he says, it's a monad. And I had no idea, right? This is 2014. Actually, that conversation was the biggest change in how I write codes ever since. And it took me a couple of months before I realized what this thing does and what these monads can do. And then you go into it and you're like, oh, there's all these functions like map and flap map and whatever it is. I did not understand. So I'm going to try to explain to you what a monad is. And the problem with explaining what monads are is this. So Douglas Crockford says, monads are amazing. They are, by the way. I love them. They are simple things, almost trivially implemented, with enormous power to manage complexity. That's what we need, right? Things that manage our complexity. But understanding them is surprisingly difficult. And most people, once they have that aha moment, seem to lose the ability to explain them to others. Yeah, so I'm going to try it anyway, right? Just let me try. If you don't get it, come to me afterwards and I'll try to explain it again. So here's the thing. What monads do is they take away side effects. And what do you mean? We have side effects in our code? Yes, tons of them. The most important one being catching exceptions. You write all this code, and then somewhere you catch an exception, and you catch it in the wrong place, or not, or you forget, or you do it twice when you should do it once, etc., etc. All these errors exist, right? So what about if you could take away exception handling from your code? And the thing is, you can. So in our code base, at that point in time, when we started using this in Java, we ended up with a single try-catch block in the whole code base. That was in the try class, basically, because, yeah, well, you need to do that once. So let me explain that to you. So if you want to work on a particular object, an instance of a class or whatever you have, this is what a monad does. A monad is basically a box. So you put that object into the box. And you're like, OK, now what? Well, now you can pass functions onto the box that transform the object that you have in there, right? It means, oh, cool, I want to win Lego too. And then transforms that thing. But while performing that function on that object inside of the box, it takes away the side effects of what that function might do. And then you do that multiple times, as many times as you want, and in the end, somewhere you'll get the object back from the box. And that means that the box can take away all of these side effects, like exception handling, logging, printing, whatever you do, right? Lots of this stuff that you would like to get rid of in your code, but is still there and would make your code much more robust. I'll show you some examples. This is a promise in JavaScript. It's actually TypeScript, but it's pretty much the same. And a promise is a monad, actually. So what it does, you execute a function to start it up, and it takes away the asynchronicity, right? That's what a promise does. And then all these then steps are basically working on the result of the previous steps, right? That is the transformation you apply on the stuff in the box. and then you get the next step and the next step. So what does this do? Well, this thing takes away asynchronicity. The same way you can take away exception handling, for instance, or fact that you have null pointers or no pointers whatsoever. All this stuff you can do, right? I'll show you one more. So this is, oh, I'm here, right? So this is a second step in the same thing, where I created this really tiny monad. I call it a when. It's in our library, by the way, so if you want to look at it and copy it, feel free to do that. And I say, okay, when the result of that thing is not defined, please reject. If you don't reject it, it will continue on the next line. This is an easy way to get out of a promise block. This is a monad, because I'm putting the result, the J, inside of the box, and then operate on that box. This thing does validation as a validation as a service, basically, right? That's what it does. Or this thing, this is a choose case. And you might think, we have choose cases in switch statement. Why would you do this? Well, this one actually takes away exceptions. So what if one of your checks on a regular choose case statement fails for whatever reason, and it throws an exception, or the function you handle in that particular case throws an exception? And this thing handles that, actually. And if you look in the actual implementation, this is also in our library, by the way, it's very straightforward. So Java, as an example, has the optional. Now, the optional is not really doing much, but it does, if you put a value in it and you don't know whether it's null, that thing will check it, and you can continue working on it even though it might be null. That's an interesting thing, right? And here's an implementation of the try monad in Java, actually. So this is what it does. It takes something in, and it executes the next function, and it takes away potential try-catch blocks. So in this code, there are no try-catch blocks. The return, by the way, of these functions is the try. So it bubbles up all the way till you get to the end of your code, and then you get out the value, or you don't even get out the value. It depends on what you're doing. But it means that there's no longer any exceptions there. And I realize this is a complex topic, so that means we're going to pass on to a simple topic. We have to talk about units. I have to do this a little bit, because it's still the case that I found many customers that I visit still don't do this, right? They write tests by hand, they put them in Excel spreadsheets, and they go through the Excel spreadsheets, and they do whatever they want to do. Don't do that, right? Avoid that stuff. Write your unit tests. And the nice thing is, Michael Fetters, who was supposed to be here, but something went wrong, I guess, but he has this nice anti-definition. He says, well, a test is not a unit test if it requires you to do stuff with something else. So it basically said, isolate your stuff. Also, you need to make sure that you can run them in parallel. That means every test needs to be set up properly and also tear down properly, right? So if you create stuff in the database to start a test, remove it from the database in the step after, because otherwise you get in trouble with other tests that might do the same thing, or later. We have that on our API test every now and then. And if you write unit tests, that's all good. So a lot of people are still learning. I'm not going to ask you who's not writing unit tests. That's not nice. But so here's the thing. What we realized over time is that when I was, this is a conversation I had with one of my colleagues, and she said, well, I just wrote all the code for this feature, and now the business has to test it. Now, the business is a nice lady called Marjolein, and Marjolein's on holiday. She is actually on holiday now, and she came back yesterday, I think. And she was supposed to test this, so we wait for her to come back from her holidays. That is not really efficient, right? So I said, well, maybe you should do some more stuff with this. And I said, well, you know what you can do? What if you just write the test instead of wait for Marjolein to test it? And she said, okay. And then she said, well, I wrote all the code. Now I need to write the tests. Fine. It's a step up, right? And I told her to break down stuff in smaller functions, single statement functions, so she could test it more easily, because that's one of the benefits of those. And then she said, yeah, I broke it down into smaller functions, and now I just need to test them. Yeah, okay. And eventually, she started doing this. She started getting this. Well, this is what I call like passive testing, right? It's nice, it works, and it helps you to do stuff. However, you can also use testing as a design technique, right? This is where you move into doing TDD. But TDD is nice, but I'm not as religious about it as I used to be, right? I like it, I do it a lot for the complicated problems, but it's not something I do all the time. For instance, if I write a React component, they're notoriously hard to test. So I write the component first and then write the test, because it's React, right? It sucks. So anyway, but you can do testing as design. Gerald Weinberg has a nice definition for it. He says, design is the progressive elimination of ambiguity. That's a cool definition, right? Dave Farley takes it one step up. And this is the step I like. He says, we need to assume that we are wrong rather than we are right. I have a lot of people in my team who say, okay, I've done this, it should work. And I'm like, how do you know? Well, I just wrote it, okay? I can look through the code and probably see stuff that is going to fail. Write me a test to do this and this and this. And I think, oh, shit, it fails. Don't do this. The way I write my test is actually quite simple. I'm sorry, because you guys are making a tremendous amount of noise. I'm not sure if that's used to be, but it's sort of I can't hear myself talk. So anyway, so I write all the failing tests first, and then I get to the succeeding test. And I do this all the time. I make sure that I run through all of the things that could fail, and then I get to the point that the test that actually succeeds. And this is the way I write my test. And I've started doing that a while ago, and I actually quite like it. So it's one of these tiny things that you could do. And this is basically more active testing, right? So that means if you write these tests, it's what I figured over time when doing this, you can write code with much more confidence. You don't have to pray for it to work, right? You know why he's praying, right? Because he's working in light mode. You don't do that, by the way. So, and by the way, you have to remember test code is code too. So 2 more things, because I have like 5 more minutes. Oh, wait, I skipped too fast. Test code is code too, right? Remember this when you refactor your code. When you talk about simpler code, that also applies to your test code all the time. This is what it needs to do. So again, in your test code, this is the same example I had earlier, making it simpler is better because it becomes easier to maintain. Every test I found in our code bases, I make it shorter. That's basically what I do. So, next thing, I need to go to another slide now. Here's the one more thing I want to tell you, and it's about learning again, right? So we get to the point where we still need to learn. The problem with learning is that you need to allow yourself to fail, right? Because learning means experimentation. And as I said in my talk this morning, a test done in order to learn something or to discover if something works or is true, which means it could also be false. That means every experiment you do might fail. If you work in a company or an organization, a project, in a team where you can't fail, get out. There's no other alternative than, well, you might try to change the company, but I would get out, actually. So here's the thing. If you do not do this, and you do not make any decisions, time moves, the universe expands, tech expands even faster, and you have to start all over again. So you have to do this. You have to act. And the thing is, Bezos says it right. I had this slide in my deck this morning as well. He said, well, if you want to do this, if you want to invent, and that's basically what we do a lot, you have to experiment. If many companies say, yeah, we're innovative and we do experiments, but if you are not allowed to fail, then you're not experimenting, then you're not innovating, then you're not learning. That's the whole point, right? And I realized that there's so much in this industry that I don't know. There's much more that I don't know than I know, right? So I couldn't know everything. So I'm doing this stuff with my team. All of us in the team have specific skills, right? We all know different skills, and together we can actually solve the puzzle, mostly, and sometimes not, and then we fail, right? And I learned this. I took away most of the rules from my team, so there's very little rules that they have to sort of abide, right? It's like basically keep this architecture intact and we'll be fine. And here's the thing. If you have clear purpose and principles, you get very intelligent behavior from people. That is in contrary to if you put up a lot of rules and regulations, people stop to think. In the Netherlands, we have an abundance of traffic signs. There are so many that people just automatically follow those rules and do not look around anymore. That causes trouble, basically, especially when you're in Amsterdam, you're driving your bicycle and, well, other people come by. Right? So basically, this is the thing that is so valid. It says, he says, you need to simplify to amplify. Simplification is the key in this industry. It's what's going to keep us alive in the end, right? And then I have to do some French. It makes me sound intelligent. But basically, Antoine de Saint-Exupéry said, well, perfection you don't reach when there's nothing left to add, but when there's nothing left to remove. So what I did with my team, we looked at what we could remove from what we were doing. And I've been working with this team for the last 3.5 years. And we removed basically everything. Well, except for the stuff that I mentioned earlier. So we don't have, we don't do Scrum nor Kanban. We don't have sprints. because they're unnecessary. We don't have a Scrum Master, because if you don't have sprints, why would you have a Scrum Master? We don't have a product owner. Everybody is the product owner of the piece of software that they are building. We don't do stories. We actually don't even document, by the way. All the documentation is in the code. We don't estimate. We don't do retros because we don't have sprints. So why would you do retros? We work together every day. What's the point in having retros? That means that, let's say on the first day of your sprint, somebody says, I'm not really happy about this thing, and they have to wait 2 weeks to be able to complain. And then everybody else has totally forgotten about it already, and they're like, what are you talking about? Yeah, that was on the first day of the sprint. Too late, right? Too late, way too late. Solve it on the same day. That's basically it. We do not do pull requests either. We do trunk-based development. Everything is short-lived. We'll just push to the trunk all the time because it saves a lot of things. You can stop doing pull request reviews. It's too late, right? You're all too late about that. And then we do this. We just solve one problem every day. Just make it small, solve the problem, go on to the next thing. And we do stuff like, well, we do mob programming, basically, which is a really nice technique. Small mobs, big mobs, and small mobs become micro teams in our case. Or we do event storming if we want to know about our business processes, and then we build it out. Done, right? Simple techniques. We didn't have the right color post-its here. It's really confusing if you only have one color post-its, event storming. So if you do event storming, get all the colored post-its. I now have them in my drawer, by the way. Too late. Or we do like lean coffee sessions, where people who have a particular topic, whatever it is, right? Even when I talk about their cats, I'm okay with that. If other people want to listen to it, we vote, and then people present, usually online, and that's it. Simple things that make it work, right? And we work in small teams that change all the time, and it's without hardly any process. Less process means more intelligence, means better work, more happy people, right? That's about it. So one more thing, and this is my mom. And you're like, why is he talking about his mom? Well, I like talking about my mom. My mom likes to talk about me, by the way. She has dementia, and I got back from a holiday. I was in Italy, and I showed her pictures. And she said, this is really nice, and why did your dad and I never go to Italy? And I'm like, well, you guys went to the same campsite in the south of France, in this small village called Vinsobre, for 25 years in a row. And the thing is, there is nothing wrong with that, right? But the thing is also, if you want to do something different, you have to go out and do this. You cannot wait until somebody else makes that decision. It's your life. And some people really like to change. This is me. I like change, right? I like driving around in a tuk-tuk, even though I have no idea how to do that. And other people just like doing the same thing. And the funny thing is, in this industry, you actually need both. There's a lot of people that do the repetitive work, that do the work that we do every day. They go out and write COBOL for 30 years in the same office building, right? These people exist, and it's really good to have those. It means I can do the stuff I want to do, because I can change. But here's the thing. If you want to change stuff, and you want to probably, even if you do one of these two little things that I start to present to you guys, there's only one person who can ignite that change. And you know who that is, right? And it's not your boss. I'm going to take a picture of you guys, by the way. So, it is you. So, yeah. That means do not ever be afraid of asking questions of which you think that they're dumb. I do that all the time. Even with 46 years in this industry on the clock, I still ask stupid questions, right? People know that. The people on my team expect that. And they're like, why is he asking that? Well, probably because he doesn't know. And there is nothing wrong with not knowing stuff. It's actually quite nice. It does mean, though, that you need to continue to learn all the time. By the way, never forget to have fun. And my last recommendation, or my one last recommendation is, if everything else fails, you just remove your node modules and you do an npm install. One more thing. Please do this before you cannot do it anymore, right? Thank you for indulging me, and I hope you enjoyed the last part of the conference and the reference.
All right, all right. Round of applause for Sander. Are you going to be around if people have some questions?
Yeah. As long as there's beer.
All right. I think we can arrange that. So if you want to see Sander, I have some questions for him. He'll be in the lounge area. Another round of applause for Sander. Please give him some love. We will, don't go away. We will start with the raffles right now. So.